Alright, so I'm going to go through worked example 5, 6, and 7 in this video. First up, worked example 5 asks you to determine the rule that represents the following arithmetic sequence. So what's the rule that if we just plug any number in, we can find out any number in the sequence? So to do that, first we need two things. Well, we need a few things. First one being our first term, which we know is 3. We know from looking at the pattern 3, 6, 9, 12, 15 that they're going up in threes. But for the purposes of this video and to make sure you guys remember, we're going to work out my D value. So I'm going to do 6 take 3. That's going to give me 3. And then I'm also going to check it with those two. So if it's the same D value, we have an arithmetic sequence. They say it is, but I'm going to check anyways. And we know that 6 take 9 is 3. So we've got the same D value. So we know we've worked that out. To find the rule, I'm going to put it into this equation. So looking at what we have, we know that Tn equals our T1 value is 3 plus n take 1, because we don't know what n is, multiplied by our common difference. We know from junior maths when we have brackets, we're going to use the distributive law and multiply them in. So that's going to be 3 plus 3 times n is 3n, 3 times negative 1 is negative 3. This means if we collect like terms, Tn is equal to 3n plus 3, which is here, take 3, positive 3, negative 3 cancels out, and we have Tn equals 3n. And we know that's correct, because 3 times 1 is 3, 3 times 2 is 6, 2 times 3 is 9, and so on. So this is the rule for our arithmetic sequence. Alright, for the next one, we know that T1 equals 40. We know the questions are based on arithmetic sequences, so we know they're going to have the common D value. I showed you how in the last session how to get the D value if you weren't sure, but this time I'm not going to do that. I'm just going to do it for the first one, and that's it, because they are arithmetic sequence, as the textbook says. So we're going to do T2 take T1. That's 33 take away 40. That gives us negative 7. So now we're going to put it into the general form for an arithmetic sequence, just like we did here, and work out our rule. So Tn equals T1 plus n take 1 times D. This means we've got 40 plus n take 1 times negative 7. That's 40 plus negative 7 times n is negative 7n. Negative times negative is a positive. 1 times 7 is 7. We know that's 40. Positive and a negative make a negative. So negative 7n plus 7. Again, collecting like terms, we're going to have negative 7n plus 40 plus 7. So negative 7n plus 47. So expression is Tn equals negative 7n plus 47. You could also write this as Tn equals 47 take 7n. It will still give you the same answer. Personally, since our n value here has a negative in front of it, I would write it like this just to make the calculations a bit easier. That way when we put 1 here, we know that negative 7 times 1 will be negative 7, and 47 take 7 will be our first term 40. Just an easy calculation for us to do. Alright, example 6. We gotta work out the 20th term in the sequence. To work out the 20th term, we need the formula first. We need our general rule. So I need to work that out first. So again, T1 is 5. Again, I'm not going to work out or show that D is the same, because it is assumed they are the same because the question is arithmetic. So I'm just going to do it for the first one. It's going to be 40 take 5, which is 35. You can go 75 take 35, that's 40, cool, it works out. So now we're going to get our formula and substitute our values. We know that T1 is 5 plus n take 1 times 35. Again, multiply 35 n. That's 5 plus 35 times n. 35n. 35 times negative 1 is negative 35. Collect like terms, we've got 35n plus 5 take 35. So that's 35n and take away 30. And that's our rule. So again, this is Tn. This is our formula for this sequence. Now we need the 20th term, so that means n is going to be 20. That means this is going to be 35 times 20, take 30. 35 times 20 is going to be 700. Take away 30, which is 670. And that's the 20th term in our sequence, 607. Alright, example 7. First part. We have to write down the rule for the arithmetic sequence. The first bit of information we're given is that the third term, so T3, is negative 1. And T5, the fifth term, is 11. From here, it's not clear how we're gonna work out the rule. So let's use what we know from our previous slides. T3 equals negative 1. We know that this should equal T1 plus our common difference twice. Likewise, 11, our fifth term, is also equal to T1 plus our common difference 4 times. Now we have two equations where we've got T1 and a D value with an answer. I'm going to call this equation 1 and I'm going to call this equation 2. And I'm going to do equation 1 take away equation 2. So, using simultaneous equations. I'm just going to forget this bit here for now and just focus on what I've got here. So, equation 1 is going to be T1 plus 4D, that's equal to 11. And I'm going to take away T1 plus 2D equals negative 1. So I'm going to go through this step by step for this video. So here we've got T1 take T1. We've got positive 4D take away positive 2D, and that's going to equal 11 take negative 1. We know that T1 take T1, well, they cancel each other out, they're gone. We've got a positive and a negative, that's going to be a negative. So here we have 4D take 2D, and that's equal to 11 plus 1. 40, take 2d is 2d. 11 plus 1 is 12. Now if I divide both sides by 2, I get d on my left hand side and 6 on my right hand side. So our common value is 6. This is great and all, but to put it into this expression, we've got that value there, we just need a t1 value. So we have two equations here for t1, so let's substitute it into an equation. So if I use equation 1, I'm going to sub d equals 6 into equation 1. Again, equation 1, t1 plus 2d equals negative 1. t1 is going to be equal to 2 times 6, which equals negative 1. That means t1 will equal negative 1. Now let's go back a step. Don't want to confuse anyone. This is going to be t1 plus 12 equals negative 1. Running out of paper. This means t1 is going to be equal to negative 1 take away 12, which is negative 13. So first term in our sequence is negative 13. Now I've got a value for t1. I'm going to put those into this expression. So we know that for part B, to find our term, we need our general expression, t1 plus n take 1 times d. We know from what we just worked out, t1 is negative 13, and we're going to add n take 1 times d, which is 6, to find the rule. This is still part A. This is going to be negative 13 plus, multiplying it in, we have 6 times n, which is 6n. 6 times negative 1, negative 6. If we collect like terms, we have 6n, take 13, take 6. Which means we've got 6n, take away negative 19. This is the rule for this expression. Now for part B, we just need to find the 50th term. So for the 50th term, it's going to be t50. If it's 50 here, it's going to be 50 where n is, so 6 times 50, take 19. 6 times 50 is 300, and 300 take 19 gives us 281. So the 50th term in our sequence is 281.